Hello, we can start, I think. We have Seamus from Workday taking us through the exception world or something. Thank you.
Okay, good afternoon everybody. My name is Seamus Mcgonigle. Today I'm going to talk to you about functional programming and exceptions in Scala. So first I'll talk a bit about our use of Scala at Workday. We're reasonably early adopters. We've been working with Scala for about 5 years. We've got production code in our projects in Dublin, and we're developing Scala over in California as well. We've got these weekly Scala meetings where we meet up each week and discuss a different Scala topic, and we're involved in the local community too. Should also say here that we've got about 30 Italians working in the Dublin office, so it felt appropriate to apply to this conference, one of which is my boss, so I better not mess this up. So first of all, I'm going to try to convince you that this is an important topic to learn about. So computer programming isn't considered cool by most people, and exception handling is probably the least cool topic of all. If you're learning about programming in college, you tend to just skip over the chapters about exceptions. But exceptions start to become really important once you get out into industry. You can bet no matter what programming job you end up in, no matter what company, having a better knowledge of exceptions will be beneficial to that company and save them money. It's also a great topic to talk about if you're coming from a Java background, because I think the exception handling, failure handling constructs available in Scala are a good demonstration of how functional code can be a lot better than imperative code. So whenever I was creating this presentation, I spent a lot of time trying to come up with examples that looked like the same way exceptions would occur in a real production system. But the problem was, as I tried to make the examples more realistic, they became more and more complex, and I ended up spending the entire presentation explaining the examples rather than discussing the actual topics. So I decided just to use really straightforward, almost trivial examples of what I'm doing. And I'm keeping the topic more theoretical than experience-based in that sense. So there's a multitude of different exception handling approaches available in Scala. I'm going to do a comparison of all the different ones, but I'm not going to try and sell you any particular one or try to figure out which is best. I'm more interested in learning about the underlying concepts between all these. I'm also going to compare how things work in Java to the approaches we can try in Scala, but I'm not here to sell you Scala or promote that either. So a lot of the time when we're programming, we're building up a lot of our code out of external APIs. And we think about these APIs in terms of the parameters that we're passing into them and the return types we're getting back. They're like black boxes. The problem arises when these functions throw exceptions. So the programmer has to not only write a way to deal with the exception when it occurs, but they have to reason about the fact that the promised return type is not going to be provided, and that introduces an extra cognitive load. So the raising of exceptions within functions, that violates the functional programming paradigm. It's a side effect. Sorry. So one of the best parts about functional programming is this concept that any expression can be reduced to a value of a defined type. But that's not the case whenever exceptions are thrown within these expressions. So to solve this, you can do two things. You can wrap the exceptions in the Scala try type, or you can use a type like either or a scholastic or to return a failure type whenever exceptions occur. So first I'm going to just talk about the try type. This is part of the Scala standard library. What's returned is either a success type containing the result of the operation or a failure containing the exception. And when you're using this, the user of the API has peace of mind because The return type in the method signature, that's a guaranteed return type, not one that might not be provided. This means that developers will be more likely to think about the exceptions whenever they're writing the code initially, instead of adding it as workaround code at the end. So now I'm just going to demonstrate the most basic possible usage of this. I'm expecting a variety of experience levels to come to these talks, so I'm doing the most basic possible thing first and moving on to the more adventurous stuff towards the end of the presentation. So I've just got a function which throws exceptions whenever you put negative numbers into it. And this is a case where it works and the results contained in the success that we get back. And you can unwrap this using pattern matching and then log an error if you want. In this case, an exception is thrown and the exception is safely contained in the failure you get back. And you unwrap this using pattern matching the same way. So if the client code programmer doesn't add a failure case when he's matching, then there will be a compiler error. So you're forced to at least think of the potential for failure before you commit the code. Often when we're developing, we'll have a number of exception throwing functions where the output of one is the input of the next. And we can do this uniquely using the higher order functions we get with try. So it doesn't matter whether the exception occurs in the first function that's executed or the second link in the chain, it will still be contained in the failure that's returned in the same way. So here's an example using map, and it's successful, so it returns the result. In this example, an exception is thrown in the first function, so it's given back as a failure, and the second function in the chain doesn't get executed, so it's safe. And here's one where the second function in the chain throws an exception, and it's contained in the failure object in the same way. Whenever one of the functions in our chain itself returns a try, you sometimes get this nasty nested result. And this can be difficult for the user to unwrap and make use of. So if you use flat map instead of map, this will unnest the result for you. So now I'm going to do something that looks a little more like a real world API. We've got three exception thrown APIs. We want to use these to write some reports for a collection of customers. And we've got separate cases in the catch block for each different type of exception. One thing to note here is that the try and the catch has to be within the same function. So in terms of functional decomposition, you can't separate the happy path from the recovery logic. Now here's the same example using try. Same three functions, they just return tries instead of throwing exceptions. And here we've separated the business logic on top of the recovery code into its own function. One thing I should explain here is that there's a recover function used in that far loop at the bottom. That's more or less like map, except the other way around. So code inside just executes in the case of a failure, but not in the case of a success. So it's good for putting your recovery logic in one place. If you're reading about functional error handling online, it won't be long till you come across this term of monad. For me, it took quite a long time to understand. There's a few different monad laws it has to obey, and has to have sensible implementations of map and flat map. And it gets even more confusing using try, because try can be used in for comprehensions, like monads normally can. It could be considered monadic design, but it's not a monad because it doesn't obey one of the laws. The same is true for the active future type of things. And I think this is particularly confusing for people who use it. So, for that reason, I don't agree with using the term monad in this context, because you can get all the benefits out of it without even knowing what that means. So I've talked a lot earlier about cleanly coding around potential exceptions, and this is a great thing, but what is perhaps more important is that we log these errors when they occur. Some people say that logging is a side effect, and if you've got logging in your functions, then they're impure. But it's not side effects that will affect any of other code in any way. So for design reasons, I think we should still call it purely functional even if there's logging in there, because it's not going to harm any code. So here's an example of how you can do this. You've got a lot of functions which don't return them anything meaningful. So if you're writing a file, you don't necessarily care what you're getting back. And you might be tempted to just check if it was successful and then move on. But in that case, your exception will silently be swallowed and you'll have nothing in your logs to find out what went wrong. It's also easy to make this mistake using for each. So if you're using for each in a try, you're saying, do this function if everything went well, and if it failed, I don't care, move on. But in this case as well, the exception will silently be swallowed. And this is the worst case you have in your production code. Errors occurring, but nothing in the logs for the people to investigate. Apart from try and try catch, there's a host of other alternatives for error handling in Scala. It's important to consider all these because Workday we're starting to produce a style guide, and your style guide will need proper recommendations for how to handle errors. The main ones are either scala-italy and scala-italy disjunction. These others are a lot less opinionated in one way, so it's not just exception objects that get returned in the case of a failure. You can define your own error object if you like. The advantage of this is that the API user knows exactly what type of exception or what type of error object they're going to get back, so you can be more specific of what's going to be returned in the case of a failure. So there's no time to do examples for all the different approaches. So compose this matrix showing the advantages and disadvantages of each. The main disadvantage of either is that it's not biased to one side or the other. So you can't use it in for comprehensions or map functions without using some conversions which are a wee bit messy. Scala-italy and scala-italy are biased towards one side. They consider one type that's been returned as a good type. So you can use these cleanly. Scala doesn't have any checked exceptions. Generally, it's the consensus among Scala developers that it's better to return a failure type than to throw exceptions at all. And I think we're moving towards replacing a lot of the existing exceptions too with compiler errors. So in the past, where you would have an illegal argument exception, if the programmer put in an illegal argument, you can prevent this using a stricter parameter type. This means that the mistake will be caught at compile time during development, instead of later on in your tests, or worse in production. Things get a bit awkward whenever you've got a try contained within an option. It's kind of difficult to unwrap these and use them. The main way to do this is to use monad transformers. If you want to know more about monad transformers, there's a talk on after the break in here, which looks really good. So if you've currently got some Scala code using try-catch, why should you go to the bother of replacing it with these types? Well, first of all, your code's more composable. It fits together better. If the APIs are black boxes, they're black boxes that kind of fit together more squarely. The APIs become more intuitive, so the developer's dealing with one real return type instead of a return type they might not get. So in functional programming and exception handling, you'll come across this idea of having a functional core of your code surrounded by an imperative shell that does all the messy database reads and I/O and things like that. If you're taking your exceptions and putting them into a try object, you're bringing those failures up into the type system, thus making the side effect and shell a lot thinner and making more of your code properly functional. It's also important to remember that this side effect in shell isn't going away, so you still need to know some of this stuff to be able to work with I/O. I watched a great talk about this concept about a week ago. It's linked there at the bottom. But he was describing if you separate your code out in this way, the different isolated functional cores separate out nicely and become easier to work into a microservices style architecture. It also makes for cleaner testing. So for every function call in each one of these APIs, there's less potential flows of control within. So it makes it a lot easier to reason about and test. Scala compiles in the JVM. It's compiles into Java bytecode, runs in the JVM. Unfortunately, we still need to know some Java to be able to handle exceptions properly. Not only are the stack traces in Java, but a lot of our code interoperates with Java code. So it means that a lot of the exceptions we're dealing with are Java exceptions. And to make things more complicated, not all Java exceptions should be handled. So there are throwables, and then there are errors below those which should never be handled. And there are checked exceptions which you should handle, and there's a subset of those called unchecked exceptions which should be handled. And this gets pretty confusing. Here's the diagram. So it's a wee bit counterintuitive because runtimes exceptions are unchecked, so things are getting less restrictive as you become more specific down the hierarchy. And this stuff's probably obvious to those of you with painstaking experience of dealing with exceptions. But this isn't intuitive. It's not easy for new programmers to learn. This here's the flowchart or rule of thumb that I use whenever deciding to handle Java exceptions or not. And again, this is probably obvious to people that have read effective Java or are experienced. But it doesn't, it works because we all learn these things for Java interviews and we know it's good practices, not because it makes sense. Another issue is whenever an exception occurs in your Scala code, the stack trace is in Java. So anonymous functions will be translated into $, a non-font $. And that's just one of many confusing things, ways it can be converted into stack trace. And this is probably because the Scala compiler is such a difficult job of converting all those fancy things, for want of a better word, into Java bytecode. And it's a nightmare whenever you've got something genuinely going wrong, and this is what you have to use to figure it out. One thing that helps in this case is this website called Stackfire. So you just paste your Scala exception in there, and it will take out all the anon functions, and it will take out any third-party libraries that you tell it to, and give you this nice diagram on the right. But I don't think you should need to copy and paste an exception out of a log into a website to figure out what went wrong. And I'd like to see something more like this in our actual logs. There's this cool library called rapture.io. So it's developed by this guy called John Pretty. He's the guy who runs the Scala World Conference, and he's one of the top people in the Scala Center as well. So one of the main things in it is this exception handling framework. So the idea here is that the client can specify whether or not they want the APIs to return tries, eithers, throw exceptions, or whatever. And the main disadvantage of this, though, is that the API designer has to know how to do it. They have to know to put the return type around this mode.wrap. And it's the same every time, so that's boilerplate. But you could hide that in your API documentation if you liked. People mean a lot of different things when they say the word exception. So when you say exception, do you mean the change in the flow of control of the program whenever the exception is thrown? Or do you mean that exception object that exists afterwards? Because they're two very different things. They mean different things as well when they talk about the logging of the exception and the handling of the exception. So those two things exist together in the catch block normally, but the logging is reporting, whereas handling is something different, something you're doing to recover from that exception. So I think we need to start using a better language for talking about these things. There are more powerful functions in our code. They're often made up of more low-level functions. If things work correctly, you can just read the high-level functions, and if the naming's good, you can understand what's going on. The issue arises because exceptions are thrown up the stack. So in your high-level business logic in your code, when you're reading through it, you'll have to deal with exceptions that get caught at that level. You'll be reading log messages for database connection errors when you should be reading about high-level business rules. So at work, a while back, we had this hack day where we got to develop whatever we liked. In the opposite spirit of a hack day, I decided I wasn't going to try and build something cool, but I was going to try and come up with a design pattern for exception handling. And I was thinking a lot of the error handling code we have is boilerplate. So it's just check, did something bad happen, then log message, check, did something bad happen, wait a while, try again. This here is the current method. So using try, it will return a success or a failure, and then we log the error. And here's what I want to do. So I just want to call a method, get it to do something, and because I've specified a logger object in my code, I want it to log its own errors. So we define this reusable error reporting strategy. It takes the method names, and if the naming's good, that'll be enough in the logs to know what exactly went wrong. There's some messing around had to be done with the stack trace because the place where it takes the stack trace is not the same as the method which failed, but because it's within the API, the number of stack frames is fixed. So you know what number of stack frames to chop off the top. So where the exception used to be thrown, we're just calling the .fail method on the handler that was implicitly supplied, and then we'll return a none or a left in the case of either. So even though it's doing its own reporting now, if the client code has its own non-boilerplate exception handling code that it wants to implement, they can still do that because they know from the type that it failed. The benefit of this is cleaner or easier to read and maintain code. When I showed this to my colleagues last week, one of them asked me, could I do this by extending one of the existing types like try? And I think you could, there's no reason you couldn't. And that's definitely possible too. So just a few final thoughts. Use a return type like scala-italy in favor of throwing exceptions whenever there's failure with your Scala code. And whenever there's exceptions thrown that you can't deal with, let's say where it's interoperating with Java, you can contain those using a try object. Be considerate of logging all the time. So whenever you become more functional and those catch blocks start disappearing, be mindful that you've still got to log everything that's went wrong. And decouple the notion of error recovery and error reporting in your mind if you're not going to do it in code. Here's a few of the references I used to put this stuff together. If you want to use try, the best place to start is the API documentation. It's pretty good. And then the Neophyte's Guide to Scala has got some great examples with higher order functions. Effective Java is also really important because we've got a lot of Java exceptions. I've also got the Oracle document and what the advantages of exceptions are, just to kind of test the antithesis of what I was about to say. That is everything I have to say to you. Thank you very much for coming to listen to me.
So if there are questions, exceptions?
Hi, I have an exception. No. Can I for no? No, you talked about the checked exception in Java code. I remember when the runtime exception were introduced, and I remember the problems with handling checked exception in Java code, and everyone seems to hate handling checked exception in Java. Can you tell us something about it, if you have an opinion about it?
Well, the check exceptions, there is one advantage of checked exceptions over try, is that the API user knows exactly what exception they have to handle. So it's saying, I'm returning a file not found exception, and that gives the developer knowledge of what they're going to get back. On the other hand, we develop property functional types. We can do the same thing by making good error objects and types we return. So, yeah, like I don't hate check exceptions. I just think a property functional method's better. Yeah, that's all I can think to say about that. Anyone else? All right, thank you.